This video, I'm going to introduce to you the idea of finding the equation of a circle. Now, there are many ways that you can have the equation of a circle, but today we're just going to think about the standard equation of a circle and how we can pick off the centre and the radius, given that we've got that. So, in front of us here, I've just got a circle, and it's just on the Cartesian plane, and I want to work out what I can know from this. So, what do I notice about this circle? Well, at the moment, it's very nondescript. I don't know much about it. However, if I introduce a point, and let's call this point x, y, so it's just a coordinate of a circle, no matter where this point is, I could drag it around. It's always going to have the coordinates which are x and y, and I think about what this line is that I've drawn to this point. Well, hopefully we should be able to make the link that this is our radius line. So, what can I do with here? I've got a point and I've got a radius line. Well, I can actually make a right angle triangle, and this is going to help me because once I form this right angle triangle coming down and across, if I know all the lengths of these, I can get some sort of equation which links everything together. The first length I want to look at is this one here, so it starts from the origin and goes out to whatever the x coordinate is, so that's going to be, well, x. The next point let's think about, well, it starts off at the origin and goes up to the y coordinate, so that's going to be y. So from here, and using Pythagoras, I can deduce that x squared plus y squared is equal to r squared. And that is our standard equation for a circle which is centred at the origin. This is something that you should have seen before from GCSE. What can I do with this then? Well, how does this differ? If I think about now sort of a transformation and I move my axes, let's say, to the left, what do we notice? Well, my point now, my equation, my circle has actually been translated to the right, and however much it's been translated to the right will be reflected in the centre of the circle. So let's say this is a coordinate of A0. So it's just moved across A units in the x direction. Well, how can I reflect that in terms of my general equation of a circle? If we think about our functions and thinking about our transformations of graphs, well, if this is a function of x, what's happened is that my x coordinate has gone along A units. So I could write this as x take away A squared plus y squared is equal to r squared. Thinking about the same idea moving vertically now, again, I'll be translating the y vertically, so it's going to be y take away, let's call it a different letter b. We get a standard form for the equation of a circle, which would be x take away A squared plus y take away b squared is equal to my radius squared. And this is really useful because from here we can pick out the centre. Well, I'm just going to denote that with the letter C, and that's going to be at the coordinate A, B. And we also know that my radius is equal to, well, it's the square root of the radius squared, so R is equal to R or whatever. You'd be able to work it out. So let's put what we know into practice. I've got two questions. Write down the equation of a circle with a radius 4 and a centre 3, -7. So straight away, I can work this out using that x minus a squared. Just be careful with your negatives. So this is x subtract 3 squared, and then it's going to be plus y subtract -7 squared is equal to my radius, which is 4 squared. So writing this out nice and neat in one line, we should get x take away 3 squared plus, and this should be y plus 7 squared is equal to 16. Okay, we should be happy with that, we should be confident. The next part is write down the radius and the coordinates of the centre of a circle. Well, the centre of a circle, x squared plus y minus 2 squared equals 9. Well, my x isn't being translated at all, so my centre is going to have an x coordinate of 0, because that's at the origin, and it's going to have a y coordinate at, well, it's going to be at positive 2. Now thinking about this, my radius is going to be equal to the square root of 9, so therefore my radius is equal to 3. So just have a look at those, hopefully they make sense to you. And then what I'd encourage you to have a look at, exercise level 1, have a look at question 1 and 2, which are find in the form of x squared plus px plus qy see. So you're just getting it in this standard form and expanding. And then the next part is thinking about writing the coordinates of the centre and the radius. So I'm going to zoom out a little bit so that you can see them, and then pause the video now, and then I'll put the answers on in about 4 seconds. So the answers to question 1, I'll just make it a bit smaller for you, are here. So pause the video and just mark your answers to question 1. And the answers to question 2 are here. So if you'd like to pause the video and write down your answers for question 2. Okay, thank you for watching. In the next video, we're going to think about how we can get it from the form in question 1 back into the centre and the radius.